let's begin. So to quickly cover the things from the final, anything that was named singleton is now named manager. Just to quickly scroll through all of these are all referred to as managers, or at the very least they are no longer referred to as a singleton. And ScreenLog is the last one. So it's Visualizer. On top of that, both the Visualizer and the ScreenLog both have an associated command factory. So if I were to go for visualizing the sphere, this now has a command pool to get the sphere commands here as well. Factory. Okay, and ScreenLog as well. Whenever we add a log, it now calls the factory instead. So here's the factory code. Alright, beyond that, the sprites. I've updated how they handle the origin. So origin now takes scale into account. On top of that, whenever we set the scale by factor or by pixel, we update the origin as well. This makes sure that when we scale our sprites, they will always rotate around the same point. So as just to showcase this, I made so that this will now move with my mouse, which I'll discuss more later. But as you can see, it is always rotating around my mouse pointer, even though it is increasing in scale. Beyond that, I have a mouse tester to showcase both, I guess, the ScreenLog's updating and also to showcase what I was working for my personal project. But first, we can see that all the visualizing works, even though I changed the system. That didn't break anything. Mouse up is a ScreenLog, as well as mouse down is a ScreenLog. If I were to freeze frame, we can see that mouse press works, and also mouse release also works. Okay, that leaks. So like I said, for my personal project, I started to make it so that inputables handle mouse inputs as well. The code for this is pretty much identical to what we were doing for the key managers. So anything that was key is now a mouse. So we have an inactive and active mouse storage. Check to see if a mouse key state combination exists. If it does exist, we move it from the inactive storage into the active one. Otherwise, we recreate it and then push it into the active. Requesting deregistration is the same. Registration is also the same. Deregistration is the same. Take the iterator from the active map and move it into the inactive one before erasing it from the active one. We have setters and getters for the iterator within the mouse manager, which I'll cover later. Then we have down, up, press, release. The only new thing for the mouse stuff is that we get the cursor state as well, so that they can check the mouse's position. For some reason, get cursor has 0, 0 in the upper left, so I just did some stuff to move it to the bottom left so it's consistent with what we're used to. And then for the destructor, we also have to now delete every request made by the mouse inputable stuff. So then we go here, we got all the mouse functions as well as the mouse storage and the other remaining mouse functions. So mouse registry and deregistry, similar to our standard registration deregistration stuff. Here. For the input manager, which I just realized I'm missing. The input manager. Here we go. So registry, deregistry, same thing as with the keys. We're not sure how many we're going to need, so we check to see if the mouse manager exists already. If it doesn't, we make a new one, and then after that we register to the inputable to the manager, and then deregistry is what we're used to as well, just deregistering it from the manager. Processing the elements, we process them after the keys, and we also delete all of our mouse managers after all the key managers as well. And just to showcase, we also have another enum class for all the mouse states as well. And we have the registry and deregistry and the processing of elements. Over to the mouse manager itself. So they are associated with a given mouse key. Registering the inputables, the same thing as what we're used to, inserting it at the front of the list, and then setting the iterator through the attorney. which is also where we have all the press down, up, and release stuff as well. So we have the setters and getters in the attorney for the mouse iterator position. We get the iterator when we deregister so that we can do the fast delete within erase. Beyond that, we have the checking mouse state. Again, same thing as what we do with the keyboard get state, but now with the mouse. If it's down, check if it's the first frame. If it's the first frame, then we process the mouse press keys, and then after that we process the down mouse keys. If it's not down, that means it's up. Check if it's the first frame. If it is, then we're doing the process release. Otherwise, we just process the up. And then anytime we process it, we just iterate through the entire loop, and we will just call the proper function from it. The next thing is the tank demo, and for the sake of time, I'm just going to change this to be 2, just to speed things up. So running this, we can see we have two yellow tanks, one with a green sphere, one with a red sphere. Green sphere is currently tracking me, while the red one is using random inputs. So the yellow tanks have 2 different states. They have a random state and a tracking state. So when the player is within this red sphere, after a few seconds, this sphere will change, and then the tank will start tracking the player. So then if I were to just get rid of it, you can see still the same victory screen, no leaks. So all that changed here is it takes the same movement code from all of the other tanks. So we have the recalibrations from the purple tanks, as well as the randomized inputs from the red tanks. Every few seconds we have this call as well, this alarm. This updates the state. So if the distance between the player and the yellow tank, if the distance is within the minimum threshold, then its sphere turns green and it starts tracking. If it's not, then it has randomized movements. And just for a bit of flavor, tracking movement is faster than random movements. Tank spawner now handles yellow tanks as well as calling the proper victory. So when you win on level 2, it moves to the win scene. Winning on level 1 moves to level 2. Level 2 stuff. And win scene still functions same as before. That is it for that. Next up is the discussion for the UI. I haven't had time to look into the menu stuff, but I do have a link there to work into next week. Beyond that, my plan for the UI components is mainly going to focus on buttons and sliders, and if time permits, to look into menus and potentially submenus as well. So handling the menus, handling the buttons or UI components in general. They will be considered game objects for the purposes of having alarms attached to them and alarm and updates attached to them as well. They will also have a UI manager within the scene to help keep track of all the updates and draws that I just mentioned. I'm not sure where in the scene update loop it belongs yet, but I do know for the draw part of the scene draw loop, that will have to happen before the draw manager, just to make sure any pop-ups of the UI, such as a pause menu, is drawn in front of all the objects within the scene. Beyond that, some of the buttons that I thought of so far is a push button, which is the standard. You push it for 1 frame, it's down. Next frame, it's up. A push and hold button, which is down, and then it will register that it stays down every frame until either the mouse is moved off the button or the mouse is released. Radio buttons, which standard bullet points. These ones have to keep track of whatever is currently the on button, so that when we click a new button, the prior clicked button has to be turned off before the new one is turned on. So we will have to use some sort of previously clicked to keep track of that, and then potentially have like a null object so that we don't have to have a constant if statement for the first initial press. Beyond the last type of button is a checkbox, which it will function nearly identical to radio buttons, but we do not need to keep track of the previously clicked, because checking one box does not uncheck a different box. And lastly, the idea of sliders, which would be used for things like adjusting volume or brightness potentially. The idea I have for that would be to have the user define X amount of grooves within the slider to have different values associated with them. So it would be something from 0 to 100, and then every extra groove would be a milestone equidistant from the left and right of the slider. as for changing the value of the slider, we would have to keep track of when the mouse is down, and if after it was down, it increases its X distance by enough to register that it moved to the next groove on the slider, and at which point we update the value of the slider. And once again, I did not have time to look into menus and submenus. That will have to be for next week. That is everything that is something that I have to discuss. The last thing that I have to do is talking about documentation. The first thing that I want to do for that, though, is jump back to here. I don't know why Doxygen is not working with it, but just to quickly showcase it, I did do documentation for the scene manager. For some reason, it's not showing up in Doxygen right now, so I'm just going to quickly showcase all of the scene manager documentation, and then I'm going to hop over to Doxygen for the rest of the work. But other than that, that is everything we need to discuss. Let me just make sure I have the most recent version. But yes, that is everything that I need to discuss, and here is the remainder of my documentation code. Oh, I forgot Scene Manager doesn't work in here for some reason, but I already showed that, so that's fine. Alright, and that is everything.